Hey guys, welcome back. So we're going to solve more equations now, but using the same idea, we're going to try and solve equations that involves negative numbers as well. And not just negative numbers, but also some distributive property and fractions. So let's try the example with a negative number, or in fact, let's try it with a distributive property and negative number. Let's say we have three equations. 3 times x plus 2 equal to 21. I'm going to leave some space to write the next equation. And we have 3 times x minus 5 equal to 2x. And then the third one is 5 times x plus 2 equal to 6x plus 3. So if we have these three equations, let's try and solve the first one first. So we have 3 times x plus 2 equal to 21. So the first operation that we have to do is using distributive property. Remember distributive property from some time ago? Distributive property means you distribute the outside number to each of the inside numbers. So you're distributing the 3 to x, and you're also distributing the 3 to 2. So you'll have 3x plus 6 equal to 21. Now it's a straightforward equation for you to solve, right? So we do the inverse operation of subtracting 6 on both sides, and we get 3x equal to 15, and we divide by 3, which is the inverse of multiplication, and we end up with x equals 5. How do I know I did the math right? Remember, we always have to check our work. I'm going to substitute the value of 5 in the original equation. What is 5 plus 2? 5 plus 2 is 7. 7 times 3 is equal to 21. So I guess my answer is correct. Does that make sense? Okay, keeping that in mind, I'm going to move on to the next problem, which is very, very similar, but except there is a negative number. It's okay, we are fine with negative numbers. Again, we're using the same concept of distributive property. We are distributing the outside number to each of the inside numbers, but keep the sign in mind as you do the calculations. Negative 3 times x is negative 3x, and negative 3 times minus 5 is positive 15. If you notice here in the previous problem, because this was a plus, there was no issue, we could just write down the plus. Okay? But here it is negative. It's actually not negative, it's minus. But minus and a negative becomes plus. Or another way to write this would be negative 3 times x would be negative 3x. And then rewrite the minus, and negative 3 times 5 is negative 15. So this is the same thing. Negative times a negative becomes positive. That's why I wrote it as positive. Either way, it is okay. The answer would be the same. So if we go ahead and solve this, so I'm going to draw a line here so we're not confused. This is equal to 2x, and then you do the same thing, but this time it's a little bit different because I have variables on both sides. I want to move the variable on one side and have the numbers on the other side. So I'm going to add 3x because this is negative 3x. To make it a zero pair, I'm doing the opposite. So I'm adding a positive 3x on both sides, and I end up with 15, because this becomes a zero pair, equal to 5x. Notice that all of a sudden everything is positive right now, and it's the same equation that you know, that you have solved. Now I'm doing the inverse operation of dividing by 5, and I get x equals 3. Again, we have to check, right? So let's plug in the value here. 3 minus 5 is negative 2, and negative 2 times negative 3. So negative 2 times negative 3 is positive 6, and 2 times 3 is 6. So 6 is equal to 6, so our answer is correct. Suppose we did this way, what would the answer be? So I'm going to draw a line here and then continue. Negative 3x minus negative 15 equal to 2x. And I'm still going to add 3x on both sides. And I end up with minus negative 15 equal to 5x. And this is the same as positive 15. So 15 equals 5x. You divide by 5. And you get x equals 3. Exact same answer. Does that make sense? Alright, let's try the third problem. Here we have 5 times x plus 2 equal to 6x plus 3. So we have variables on both sides and numbers on both sides. So let's try this. So we're doing the distributive property first. Distributing 5 to x and 5 to 2. So we get 5x plus 10 equal to 6x plus 3. And let's see which side has a smaller x, so 5x. So I'm going to move the x over to the other side. So I'm subtracting 5x on both sides. So you end up getting 10 equal to x plus 3. Now it's easy, right? It's just a one-step equation. So I'm going to subtract 3 on both sides. So you end up with 7 equal to x. Again, check your work to make sure it's right. If I plug in the value of x on the left side, it is 5 times 7 plus 2. We want to check if this is equal to 6 times 7 is plus 3. So 5 times 7 plus 2, 7 plus 2 is 9. 5 times 9 is it equal to 42 plus 3. 5 times 9 is 45 and 45 is equal to 45. So x is equal to 7 is the right answer. I hope this makes sense, but just for more practice, you are going to be working on your problem set, which is in a Google document called Solving Equations Lesson. Okay, so click on that and there will be a set of equations for you to solve. So you're writing down the equations, you're writing down what is different in each equation and how did the answers change because of that equation. So for example, the first one would be, if I compare these three, the differences between these two is it has positive number outside the parentheses, this one has a negative number outside the parentheses, and this one has only a number on both sides. This has variables on both sides, and this has variables and numbers on both sides. And based on that, the answer changes. Does that make sense? Okay, go ahead. You have about 20 minutes to finish working on the set of equations given in that Google Doc and filling out the table. I would say about 25 minutes. All right? And I will see you in about 25 minutes in Google Chat. See ya.